Hello, this is Dr. Brown. In this video, we're going to continue in our modeling unit. And in particular, we're going to be covering quadratic functions, quadratic models. I'm sure you've heard of quadratic functions. A quadratic function has a form y equal f of x equal ax squared plus bx plus c, where a, b, and c are all real numbers, real constants. And a cannot be zero, because if a were zero, then there would be no x squared term, and so it would not be quadratic. The domain of a quadratic function is a set of all real numbers. In other words, x can be anywhere between minus infinity and plus infinity. The graph of a quadratic function, as you know, is called a parabola. If a is more than zero, it opens up and has a minimum value. If a is less than zero, it opens down and has a maximum value. Now you need to understand some of the features of a quadratic function. First of all, if you look at the quadratic function, it has an axis of symmetry. In other words, this dotted line here splits the parabola into two pieces that are exactly equal. And the x value of that point is x equal minus b over 2a. Now, the x-intercepts, that's where y is equal to 0, can be calculated by the famous quadratic formula. And I'm sure you've heard this before. We're going to be using this quite a bit in this section. You can have the formula by your side as you do the calculation. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. There's an alternate form of the quadratic function, which is y equal f of x is equal to the same a times x minus h quantity squared plus k, where h is equal to the x value of the axis of symmetry, and k is the minimum or maximum value of the function, which you get just by plugging in minus b over 2a into the function. Now, the solution to the quadratic formula, that is where y equals 0, f of x equals 0, is given by x equal minus b plus or minus the square root of b squared minus 4ac all over 2a. The b squared minus 4ac under radical sign is called the discriminant, and it tells us what types of roots we will have. If b squared minus 4ac is more than 0, there are two real distinct roots. If it's less than 0, there are two complex conjugate roots, which you may have heard of. We will not be studying those that much in this section, but that would give you complex roots like a plus b I and a minus bi. If b squared minus 4ac equals 0, it turns out there are two equal real roots. Let's take an example here. F of x equal x squared plus 4x plus 3. We want to identify the coefficients. A, of course, is 1, b is 4, and c is 3. Let's determine the type and number of roots. B squared minus 4ac is equal to 4 squared minus 4 times 1 times 3 equals 16 minus 12 equal 4, which is more than 0. There are two solutions. Does the function open up or down? Since a is more than 0, it opens up. And does the function have a minimum or a maximum value? Since it opens up, it has a minimum value. And now let's find the axis symmetry. Since x is equal to minus b over 2a, that would be minus 4 over 2 times 1 equal minus 2. So x equal minus 2 is the axis of symmetry. And let's find the vertex by substituting the h equal minus b over 2a into the quadratic function. Remember, h is equal to minus b over 2a is minus 2. So k is equal to alpha minus 2. And that would be minus 2 squared plus 4 times minus 2 plus 3. And so k equals minus 1. So the vertex is minus 2 and minus 1. So let's find the x-intercepts. Again, the equation is x squared plus 4x plus 3. A is 1, b is 4, c is 3. And we're going to use the quadratic formula, and we get x equal minus 4 plus or minus the square root of b squared, which is 4 squared minus 4 times 1 times 2 times 3, times 3 divided by 2a, which is 2 times 1. And this will become minus 4 plus or minus the square root of 4, all divided by 2. So x would be minus 4 plus or minus 2 over 2, which would be minus 6 over 2 is the first root, and minus 2 over 2 would be the second root, and that would be minus 3 and minus 1. So the x-intercepts are minus 3 and 0, and minus 1 and 0. That's where y is equal to 0. So let's graph this. The vertex minus 2, minus 1. Axis of symmetry is x equal minus 2. And the x-intercepts are minus 3 and 0, and minus 1 and 0. And the y-intercept is 0 and 3. So putting all this together, our y-intercept is 0 and 3. The vertex is minus 2 and minus 1. And that would be right about here. The x-intercepts are minus 1 and 0, which would be here, and minus 3 and 0, which would be there. And graph would look like this. And since I'm not really great drawer. I'm going to do this on a website that will draw it perfectly for you. There's what it looks like after you graph it. Now let's go to an application problem. A ball is thrown in the air, and the equation for the height that the ball reaches is given by minus 16t squared plus 60t plus 6. And this is a height in feet as a function of time. So it's not a function of x, it's a function of t. We want to calculate the maximum height the ball achieves. And we want to show all our work and find the time when the ball will hit the ground. So let's use the discriminant to determine the type and number of solutions. A is minus 16, B is 60, and C is 6. So B squared minus 4AC is 60 squared minus 4 times minus 16 times 6 equals 3696, which is more than 0. So there are two solutions. I want to point out here that the minus 16t squared in the equation is due to the force of gravity, which comes from physics. For gravity on the Earth causing the ball to return to Earth. Now, the 60 comes out because the ball is thrown up at a speed of 60 feet per second. And we'll see how this equation can change if a projectile goes up at a different initial velocity. And notice the 6, the constant, is how high the ball is when it leaves, say, the pitcher's hand or whoever is throwing the ball. Now, does the function open up or down? A is less than 0, so it opens down and it has a trajectory like this. And does it have a minimum or a maximum? It's going to have a maximum because it opens down. Now we want to find the axis of symmetry, which is the time the ball reaches its maximum height. And H is equal to minus B over 2A is equal to minus 60 over 2 times A, which is minus 16, which is equal to 1.875 seconds. So in 1.875 seconds, the ball reaches its maximum height, and we'll calculate the maximum height by calculating the y value of the vertex, or the h value of the vertex. So k, which is the h or y value of the vertex, is going to be F at 1.875, which is really h at 1.875, which is equal to minus 16 times 1.875 squared plus 60 times 1.875 plus 6 is equal to 62.25. So the vertex is 1.875 and 62.25. Now we want to find the intercepts. Remember, we're talking about the function h of t is minus 16t squared plus 60t plus 6. And the a is minus 16, b is 60, and c is 6. And so the t-intercepts would be minus b, which is minus 60, plus or minus the square root of b squared, which is 60 squared, minus 4 times minus 16 times 6, all divided by 2a. 2 times a is minus 32. So let's plug in and we get minus 60 plus or minus the square root of 3984 divided by minus 32 is equal to minus 60 plus or minus 63.1189. I'd go out to about 4 decimal places, divided by minus 32. And you get minus 123.1189 divided by minus 32. And 3.1189 divided by minus 32. So if we'll do that in order, the first one is minus 0.097, and the other is 3.847. And this is really the zero, or the time when the ball hits the ground. This particular one, since it's negative before t equals 0, it really doesn't mean anything in this particular problem. This is the one that matters. Now we're going to graph the function. Remember, the vertex was 1.875 and 62.25. And so that is about right here. 1.875, 62.25. The 0 is at 3.x. The x-intercept was 3.847. And of course, y equals 0. And that would be about right here. The other 0 was slightly to the left of the y-axis, minus 0.097 and 0. So just right there. And so the trajectory looks like this. I'm not a great drawer, but this is what the trajectory looks like. And if you put it in an app that can calculate on the web, you get a nice graph like this. The ball goes up, and after 1.875 seconds, reaches its maximum height of 62.25 and reaches the ground at t equals 3.847 seconds. And this is a graph of the function, but since we start at t equals 0, the one to the left really doesn't mean anything. Another application problem. We have a bottle rocket takes off at a velocity of 200 feet per second from a height of 2 feet, and the constant for gravity is -16, so we're still on the Earth. Here, A would be -16, B would be 200, and that turns out to be the initial velocity of the bottle rocket. And C, which is the height at which the rocket starts off at, is 2 feet. And so we want to use a discriminant to determine the type and number of solutions. You get b squared minus 4ac equal 200 squared minus 4 times -16 times 2 equals 40,128. It's more than 0, so there are 2 real zeros. Does the function open up or down? A is less than 0, so it's going to open down. And does it have a minimum or maximum value? Since it opens down, it'll have a maximum value. Now, let's find the axis of symmetry, which is the time the rocket reaches its maximum height. The axis of symmetry is minus b over 2a, is minus 200 over 2 times -16, which is 6.25. So at 6.25 seconds, the rocket reaches its maximum height. Let's find the vertex, the k value, which is the h value, or we could call it y value. The vertical max is going to be h at minus b over 2a. It's going to be h at 6.25 is equal to -16 times 6.25 squared plus 200 times 6.25 plus 2 equals 627 feet. So this rocket reaches a maximum height of 627 feet, and the vertex is 6.25, and 627 would be the coordinates of the vertex. Now let's find the intercepts. Here again, A is -16, B is 200, C is 2. So the t value of the intercept are going to be -200 plus or minus the square root of b squared minus 4ac, which is 200 squared, minus 4 times minus 16 times 2 divided by minus 32. And plugging in, we get minus 200 plus or minus the square root of the discriminant, which is 40,128 over minus 32, which is minus 200 plus or minus the square root, plus or minus 200.3197 divided by minus 32. And this becomes minus 0.3197 divided by minus 32. And minus 400.3197 divided by minus 32. And this first one is like minus 0.0097, which I would round off to minus 0.01. And the root that really matters is 12.5099, which would be rounded off to the nearest hundredth, or 12.51. So in 12.51 seconds, the rocket comes back and hits the ground. Now we put in the vertex, 6.25 seconds, reaches a height of 627 feet, hits the ground in 12.51 seconds. And the other zero, of course, is very close to 0, but it really doesn't have any reality in this particular situation because we're talking about t more than 0. Another application problem. The cost of producing X crates of pencils is given by this cost equation, C of X, 1/2 X squared minus 10X plus 1,000. A is a half, B is minus 10, and C is 1,000. The discriminant, B squared minus 4AC, equals 10 squared minus 4 times 1/2 times 1,000 equal minus 1,900. So there are two complex roots. So it will not have any real zeros. No real zeros. Does the function open up or down? Since A equal 1/2 is more than 0, it opens up. And since it opens up, it has a minimum value. So let's find the axis of symmetry, which would be the number of pencils that produces the minimum cost. X equal minus B over 2A equal minus 10 over 2 times 1/2 equal 10. So the optimal number of pencils is 10 And now we want to calculate the other part of the vertex, which is x equal h equal minus b over 2a. We want to find k is going to be c at minus b over 2a. Of course, minus b over 2a is 10. So we want to plug in 10. So k is equal to 1/2 times 10 squared minus 10 times 10 plus 1,000 equals 950. So the vertex is at 10 and 950. And we already know that there were no intercepts, so there are no intercepts, at least no x-intercepts. The y-intercept would be c at x equals 0. Just plug that in, and remember c was equal to 1/2 x squared minus 10x plus 1,000. Plug in x equals 0 and you get 1,000. So the y-intercept is 0 and 1,000. On the next page, I have graphed the function. And with a vertex of 10 and 950, the y-intercept is 0 and 1,000. And there are no x-intercepts. And I sort of blew the scale of this up so that I just show from 920 up to a little over 1,000. And you see, obviously, a parabola. If you did this from 0 to a little over 1,000, you'll see a slight parabola here with the same vertex. The last example we're going to look at is a newspaper has developed a formula to calculate the revenue R as a function of the quarterly subscription rate fee, which is X. So the revenue formula is minus 2,500 X squared plus 159,000 X. We want to determine the optimal fee that will maximize the revenue and sketch a graph. So what we want to do is find the vertex H is equal to B minus B over 2A, which is going to be minus 159,000 over 2A, which is 2 times minus 2,500 is equal to 31.8. And that would be $31.80 would be the optimal subscription price in order to maximize the revenue. the K value is just plugging in 31.8 would be minus 2,500 times 31.8 squared plus 159,000 times 31.8, which is equal to 2,528,100. So the vertex is 31.8 and 2,528,100. And if we graph this, see the vertex and calculating the zero, you can do that yourself. You'll find that it's 63.6. I suggest that you go and use the quadratic formula to verify the zero here that I have. It's just using the quadratic formula, and you'll see that it's exactly that value. And the other value is zero. So that is the section on quadratic functions.